Alright guys, now it's recording at 3 frames per second, which is perfect. The file won't be too big. Now, in the diagram we see that PQ is perpendicular to SQ. That means it's the right angle triangle. What else do we see? We see that SR is 60, angle PSR is 42, and PQR is 65. Find SPR. Now, which one is SPR? S to P to R. SPR is this guy here, yeah? So, straight angle makes that 115 or 180 when you add both of them together. Add up the red, the green, and the blue should add together to give you 180. So what does that make this one up here? 23? 23, great. Now, calculate PR to the nearest meter. Well, what we have here with PR is this triangle here. PR is in PRS. We got a 42, we got a 115, and we got a 23, and we got this is 60. I'm capable of using the sine rule here. So I'm going to use, I want to calculate PR. PR I'll call X. So,
42
X over sine 42
equals sine 23. Oh, 60 over sine 23.
60 over sine 23. Okay. Cross multiply. X is going to equal 60 sine 42 over sine 23. And what's your answer? And do we get this?
103.
103?
Yeah.
102.75.
And round up to nearest meter, 103. Okay. Hence or otherwise calculate PQ to the nearest meter. Well, if we look at PQ, we now know that this is 100 and, what did you say was 100 and?
3.
Before we rounded off?
2.75.
Alright, 102.75, okay? And we want to find out what P to Q is. What type of triangle is this?
Right angle.
It's a right angle triangle, isn't it?
Yeah.
So we have 65. We know the hypotenuse to be 102.75. Oh dear. 102.75. 65. So we need the opposite, don't we? What function should we use? So we can use SOHCAHTOA now because it's the right angle triangle. What do you want me to use? Sine, cos, or tan? Sine, because we're looking for the opposite side. So sine 65 equals X over, anybody?
102.
Then 102.75 sine 65, and what you get for that?
93.
What?
93.
93 meters.
Does the sine 65 have to go underneath?
No, the 102 went up to meet it.
Oh, okay.
So the 102 went from here up to there. Division on the right, multiplication on the left. I just switched it around as well.
Is that?
Ready to move on? Yeah? Okay. Now, this one. We have 3 sides. 1, 2, and 3. 21, 7, 8, and 10. Okay, which one's the smallest angle? We have a choice. We have angle A, angle B, or angle C. A. Which one's the biggest angle?
B.
B. The smallest angle faces the smallest
Number.
side. So, we're going to figure out this one here. I'm going to have to use the cosine rule or sine rule. Well, if I try the sine rule, look. If I did a sine rule, I'd be left with 2 letters I don't know. But if I use the sine rule, I'd be left with 2 letters I don't know. But if I use the cosine rule, I'd be only left with 1. Observe. If I'm looking for the smallest angle, that's big A. What's small A going to be?
10.
So, 10 squared equals
21.
17 squared plus 21 squared.
What?
Your two sides are B and C.
We not just do 21.
10 squared.
Yeah, I know.
You have 7 squared plus 21 squared minus 2 times 17 times 21 cos A. What did I say about this part here? It's all together. Can't be separated to the end. So we're going to get hundredths. Can anybody tell me what 17 squared plus 21 squared is? No? Awesome. Best class ever. 730. 730. And I'm going to tell you what 2 times 17 times 21 is? 714. How do we finish this off? Yeah, are we expecting A to be in an acute angle or above 90?
Q.
So below 90, aren't we?
Yeah.
So we're expecting a positive value of cos, yeah? Remember? ASTC, cos is positive from 0 to 90. It'd be negative if it was 90 to 180. We're expecting a positive value. So, bring over to 730, it becomes minus 630. Then divide 630 by 714.
Wait, can you bring it out? I thought it was stuck.
The 730 wasn't.
Oh, sorry. I thought you were going to
And now this one was, the 714 is multiply on the left, which makes it divide on the
Right.
sorry, multiply on the right, which makes it divide on the
Minus
left.
630 divided by minus 7.
Yeah, same thing. 15 over 17. So, minus 630 divided by minus 714 equals cos A. Cos A equals 15 over 17. Everybody okay with that? What's cos inverse 15 over 17? 28 degrees, which is what we were asked to do. But we still haven't answered. Sine A equals 8 over 17. Now, what does cos A stand for again? Cos stands for
So over J. Oh.
17 and 15. Do Pythagoras' theorem. Plus, everybody knows how to do that, don't they? The answer would be x equals 8. And therefore sine A is, anybody? Opposite over hypotenuse? 8 over 17. Cool. Okay. Which one am I doing? 20? Yeah? Area. Go with that. Now, a half 7 times 6 root 2 sine C equals 21. A half 7 6 root 2. 21 root 2. 21 root 2 sine C equals 21. What cancels both sides? Root 2 sine C equals 1. Where does that root 2 go?
Underneath.
So what am I going to get?
1 over root 2.
Sine C equals 1 over root 2. Are we talking about an acute angle or a obtuse angle for this? Acute, is it? Okay, so there would be two options, wouldn't there? There'd be sine inverse 1 over root 2. I could be either talking about 45 degrees or 135 degrees. Why is 135 degrees might be allowed in this question? Because sine is positive in the second quadrant. So there could have been two answers. I think just by looking at it, we're saying, look, it's got to be 45. It shows clearly it's an acute angle in the question. Is that alright? Find PR correct to one decimal place. What are we trying to find now? This guy here? And we know this to be 45 degrees. What do you think you can do? Anybody?
Split it in two, maybe.
Nope.
Cosine.
Cosine rule. The reason you can't split it in two is you don't know it's an isosceles triangle. Only if that was an isosceles triangle could you split it in half and do Pythagoras and stuff like that and figure it out that way. But no, it's not an isosceles triangle. So a squared equals b squared plus c squared minus 2bc cos a. We're looking for degree. We're looking for x. That means that's that one, and the angle opposite it, 45, which means that one there. Now, x squared equals 7 squared plus 6 root 2 squared minus 2 times 7 times 6 root 2 cos 45. Does somebody want to tell me what that is?
205.
Square root 205.
14.3.
Who got it out? Okay. Under SE? No, it doesn't matter. Make sure you remember. Moving on? Moving on? Okay. This one. They all cut through their midpoints, don't they? So, this is a weird one, alright? Let me explain how this one works. You see that there? That's a right angle triangle. Can anybody tell me what that's a right angle triangle? Imagine I call this point D. Yeah? I see 3 right angle triangles. You? I'm going to label them all now. The first right angle triangle I see is A to D to C. Second right angle triangle I see is
A to D to B.
yeah, that's one as well. BDC. The third right angle triangle is one you named, Whelan. What is it?
A to D to B.
Yeah. A, D, and B. Happy enough with that? Now, they're all midpoints, aren't they? I would say D to C is what length? D to C, anybody? 8. Half of the 16. What about A to D? What about D to B? 4.
Do you know that though, or can you just guess that?
No, I'm not guessing because it's half. It says it's the midpoint.
Oh, right, grand.
So it's the midpoint of the 8 and the midpoint of the 16. Now, what's D to B? D to B is also
8.
sorry, 4. Sorry, my fault. I wasn't leading the question. 4. C to D?
8.
8. And finally, A to D?
8.
8. So we're going to do Pythagoras' theorem a few times, aren't we?
Yeah.
Call this one x, yeah? X squared equals 8 squared plus 8 squared.
Square root of
Square root of 128. 8 root 2. Are we right with that? Square root of 8 root 2. 1 down. What about the next one? 8 squared plus 4 squared. I think it's 8 root, y squared equals 80. What's the square root of 80? Somebody sort of tried to say something there. 4 root 5. Okay. So, these two are the same, aren't they? They're both 4 root 5. Now, all of this gibberish aside, can anybody tell me? Now, yoink, yoink, yoink. Okay, what are the length of those 3 sides? A to B, guys? A to B?
Is
4 root 5. C to B? And A to C.
8 root 2.
Okay, what are we looking for?
The
The area. Well, do we have a formula? Have we have a formula in our locker that doesn't require?
Sorry.
Do we have a formula in our book that doesn't require to know any angles?
Yeah.
What is it?
Base by height.
Only if it's a right angle triangle. Oh wait. It is isosceles though, isn't it?
Yeah. Wait, is it? Yeah.
Alright, so you have two choices. I'll give you both your choices now, okay? So Whelan says a half base by height. Whelan's not wrong. So here's your two choices. Choice A, Whelan spots as isosceles. So that gives Whelan an extra options. Okay? Option A. Oh dear. Right, I'm actually going to give you your three options here. Okay, you need tools to do this. Right? This is a special case because it's isosceles. Because it's isosceles, when you draw a line on straight through, it cuts the other one in half. So if this is 4 root 5, that will make that 4 root 2. Do Pythagoras' theorem and determine what the height is. 4 root 5 squared equals 4 root 2 squared plus h squared. 80.
Or 2.
3 2 plus h squared. H squared equals 48. H equals root 48. Root 48, anybody? 4 root 3. Okay. Now, Whelan, if your height is 4 root 3, what's your base length?
4 2.
So your height, no, the base length is the full thing.
So 8 root 2.
8 root 2. So, what Whelan would have went for is, and he made the right decision here. Oh, dearie me. What Whelan did here was he would have said it's a half 8 root 2 by 4 root 3. Anybody want to tell me what that is? I think it's 16 root 6. And what is 16 root 6 in the calculator? 16 root 6 or 39.19. Who did it that way? That would only work because of what reason? Isosceles or equilateral. That would not work for a regular triangle. Is that right, Rory?
Right.
Okay. Now, and what we're going to do next is a different trick. Trick number 2. Trick number 2 you learned in the last exercise. We're not going to use this formula. We're going to use 4 root 5, 4 root 5 and 8 root 2. S equals A plus B plus C all over. A equals S bracket, S minus A, S minus B and S minus C. And we remember that trick.
Yeah. What's S?
S doesn't have a proper name, but what S will do for you is it will find the area for you when you put it into this equation on the bottom.
Yeah.
Okay? Add all three sides together and divide by 2. 8 root 2 plus 4 root 5. This 4 root 5, isn't it? Plus another 4 root 5. That there divided by 2. S equals 4 root 5 and 4 root 2. Go with that. Now, what's S minus A? S take away A, anybody lads? What's A? Well, we'll label each side. We'll call this one A, call this one B, and call this one C. What's S minus A? What's 4 root 5 plus 4 root 2, take away another 4 root 5. It's what Hero said, it's 4 root 2. S minus B would be 4 root 2. And finally, S minus sig. Sorry? Okay. Now, what you're saying is if I put all this into a gigantic, an absolutely gigantic square root, I should get 39.19. Let's find out. What comes first? The S value. What's the S value again? Okay. What's S minus A? S minus B. And finally, S minus sig. 4 root 5. And we're hoping that it'll come out as 16 root 6 or 39.1. There you go. On the money. What's the second way of doing it? Anybody know a third way of doing it? Nobody knows the third way?
Half AB sine.
You can use half AB sine C, but what you guys are telling me is you can't use a half AB sine C because you haven't got enough information. Would you agree with that? So why don't we use the cosine rule and find out one of the angles? So do you understand what you can do? Use the cosine rule, find out angle X, and then after that you use a half AB sine C. That's easy enough as well, isn't it? That one, and that one. Happy enough?